Assalamualaikum and hi everyone. Our group will be presenting about a short story that demonstrates a lot of dynamic learning outcomes. The story begins like this. Afi is Daniel's best friend. They like to do something together.
Okay, finish my work. What to do right now? I think I want to call Afiq.
Go. Hi, Daniel.
Hi Afiq. How are you, Afiq?
Oh, I'm fine. How about you?
Yes, I'm fine too. Afiq,
Yes.
I'm very bored right now. Do you have any suggestion on what activity that we can do?
Oh, so you are bored right now. I think since you are very active on sport, right? So why don't you play basketball?
Great idea. Since I have basketball in my house, so why not? Sure,
Yes.
I can play basketball.
Okay.
Yeah, thank you, Afiq.
Alright, no problem.
Yes. Now I will play basketball.
I think I want to play tennis too.
Have you guys watched the video? Very interesting, right? Did you know that from those real life examples, we can demonstrate the dynamic learning outcomes? Now let's start with level 1 in solving the accelerating particles.
Next, this is the dimension of LO1. The problems are: what is the maximum height of the ball and the time when it returns to original position.
I will be explaining about the calculation for accelerating particles for LO1. So in our case, for the ball that we're throwing upwards, we can see that the initial velocity of the ball is y and s negative 1, while the final velocity is 0. And we have the acceleration as negative 9.81 as the ball is throwing upward. And we have to find the time taken and also the maximum height of the ball. By using all the information that we have, we will be choosing the equation that suits for the information that we have. By looking at the diagram of the equation of linear motion, we will choose the first equation, which is v equal to u plus at, to find the time taken. And then we will choose the third equation, which is s equal to ut plus half at squared, to find the maximum height. We will not be choosing the second equation because it doesn't provide the acceleration information in the equation itself. So for the fourth equation, we cannot choose that equation because it does not provide the time taken in the equation itself. For the time taken, as we use the v equal to u plus at, we will insert the information of the initial velocity, which is u equal to 5m negative 1, and also the final velocity as 0. And we get the time taken as 0.51 second. Now we proceed with the third equation, which is s equal to ut plus half at squared, to find the maximum height of the ball. So as we insert the information in the equation, we can see that the maximum height of the ball is 1.27 meters. So the ball has been throwing up in the air with the highest maximum of the 1.27 meter in the time of 0.51 second. Thank you.
So now, let's move on to LO2, in which to solve problems of accelerating rigid bodies in 2 dimensions.
This is the projection of after being hit by the racket. So we didn't know the maximum height. I put 3 points which will be labeled as A, B, and C. In projectile motions, there are 4 important parameters which are range, velocity, time of flight, and also maximum height. In this picture, we have the range and also the velocity. So 2 unknowns that we need to find are the time of flight and maximum height. From the picture below, The velocity can be divided to two components, which are x component and y components. By using the coordinate system, we can find the velocity of the x component, which is 5.362 meter per second, and also velocity of y component, which is 4.50 meter per second. So now, we will be using the kinematic equations to solve these questions. These are the equations for horizontal and vertical motion that will be needed to solve the questions. Time of flight. Since the range are known, we can find the time of flight using the horizontal motion equation, which is the first equation. xb is the distance projectile launched from the initial to B points. xa is the initial point of projectile launching. vax is the velocity of x component at point A, while tab is the time of flight from A to B. So plug in all the equations and we got the answer, which is 1.12 seconds. Maximum height. At maximum height, h, the velocity of y component at point C is 0. Since velocity at point A is known, we can determine h directly without considering the time of flight from A to C. We will be using the last equations. Plug in all the information into the equations and we got the answer, maximum height equal to 1.53 meter.
Now last but not least, let's continue for the third LO, which involve the kinetic and kinematic problems in vibrating particles. Let's go.
Now, I will explain about learning outcomes number 3, in which to analyze kinematics and kinetic problem in vibrating particles. As you can see from this picture, the ball being hit by a fig will bounce into the ground and produce multiple bounces until it stops. So this example is different from LO number 2. So the distance from the ball to a fig is 7 meter. The height of the ball being hit by a fig from the ground is 0.5 meter. The initial velocity of the ball is 7 meter per second, and the angle of the ball being hit from the horizontal component is 40 degrees. So we need to find what is the velocity of the ball after it bounces and the angle of the ball after it bounces, which is theta n. So first we need to know what is the final velocity and the landing angle or theta f of the ball. So the final velocity can be resolved into two components, which is Vfx and Vfy. So to find the horizontal component, we know that the initial horizontal component of the ball is the same as the final velocity of the horizontal component. So Vfx is equal to 5.362 meter per second. So to find the vertical component, we use the formula Vy equals to Ay times t. So we get the final velocity for the vertical component is negative 8.351 meter per second. So to find the final velocity and the landing angle, so Vf or final velocity can be find by using the horizontal component and the vertical component of the final velocity. So we get the Vf equal to 9.92 meter per second. For the landing angle or theta f, we use the tangent inverse times the vertical component divided by the horizontal component. So we get the landing angle is equal to negative 57.3 degrees. Next, to find the velocity after the ball bounce is to find the horizontal component of VA, which is Vix. We can use the formula of mv1 equal to mv2. So we get the horizontal component of VA is equal to 5.362 meter per second. For the vertical component, we can use the coefficient of restitution formula, which is equal to VAY divided by VFY. So we assume that the coefficient of restitution is 0.7. So we get the vertical component of VA is equal to 5.846 meter per second. So to find VA, we use the same formula as previous calculation. So we get VA is equal to 7.932 meter per second. To find the angle after the ball bounce is also using the same formula as previous calculation, and we get the angle of the ball after it bounces is 47.5 degrees. That's all from our group. Thanks for watching.